So obviously, thank you very much. As you said, my name is Shawn Capper. I'm the CFO for Symbioses. For the past 3.5 years, we've been working on a protocol to develop and essentially create a decentralized computing, storage, and IoT platform. Obviously, we know that there's a massive amount of data that's being created at this point in time. I guess the question I have for the audience is, how quickly do you think it will be duplicated if we still run at the current rate? Kind of guess in terms of years or months. If just shout it out. 3 months to duplicate all of the information that's been developed. Sorry, all the information has been developed since in history, digital information. No, a little bit longer.
Yeah, it's technically 2 years. So essentially, every 2 years, we're doubling the amount of existing information that's out there. And you can think of why. Go through all the projects that have been presented today. Think of what's happening in terms of using Instagram, in terms of using Facebook, in terms of cookies that are on your searches. So we can see that more and more data is going to continue to be needed to be stored. Essentially, even in terms of wearable devices and in terms of new and smart TVs and in terms of new and smart refrigerators, they are processing data and they're sending information as to whether you need to buy more flour or brownies or milk at the store, and it's still passing and it's still being stored in some place. What we see though is all this information is great, but it really doesn't turn into actionable information unless you can essentially analyze it or compute it. And in order to do so, you need massive amounts of computing power. And we're seeing that the total market between both cloud computing and cloud storage in essentially 2 years will breach $400 billion. You obviously know the main players that exist today, and some people have talked about the different powers of them. You can see that both Amazon and Google actually represent over 50% of the market. IBM, Oracle, and Microsoft, if you aggregate all of them, they represent over 70% of the market. As you can see, as people have been pointing out, they are all US-based companies, and that's the reason why 70% of all internet traffic actually runs through Northern Virginia, United States. This is what I actually was just in Berlin and I ran across this poster, and for anyone that doesn't speak German, essentially saying that who knows more about you? The NSA, the Stasi, which is the East German, we'll call them the KGB, or Facebook. And it just shows you that when you're turning over your information, there's always questionable about where is that information and how is it being used. And so in a centralized environment, that is an issue. The other issue within the centralized environment is that they don't have the computing power closer to the end users. And it's especially inefficient in terms of Internet of Things. So when you want either a factory floor to start to run, you need it to react in milliseconds, not in seconds. This is actually a paper that was put out by Cisco. It's a white paper, and I just included the headline, but you can go to their website and actually see a little bit more about this. They put this out essentially 2.5 years ago, talking about moving computing capacity closer to the end use. When we developed the protocol, we obviously had to overcome 2 main variables, and it's the same variables that we see within the blockchain. One, we have to make sure that if you think about the latency of the transactions, we can't have someone waiting for it to get verified in order for them to be able to process it, because it's either going to say, I don't want to do it, or I'm just going to continue to use Amazon or Google. The second one is in terms of scalability as well. So you've seen breaches in terms of blockchains already, and we've come up with a way to basically do this off-chain, in which we can bring it back on the Ethereum chain after the proof of work has been established, but we can also aggregate all of the transactions into one, and so that we have much more scalability than just using a normal Ethereum chain as well. The other issue that we're seeing, and was touched upon, is that there are multiple competitors in this space. And while we don't want to call them competitors in our system, because interoperability has been the issue. But in our case, we actually made a protocol that can talk to everyone, so there aren't silos. We see all of these players as complements to our system, so we can actually unite all the disparate systems at once. Security is a big issue that is starting to get talked about a little bit more, and everyone wants to talk about Docker containers. I am not the technical expert. As I said, I was a CFO, but I'll give you the general explanation. Docker containers can still, when they reside on a host system, they can still be penetrated, and essentially they can launch a virus within your system. We had to come up with another way to essentially isolate the system, and we refer to it as our sandbox. It's a very similar system to what actually Apple just put out in their newest version. So we're on the right track, but we know nothing is 100% certain, but we want to improve the certainties as much as we can. In terms of the SIM token, why did we have a SIM token? Why do we use blockchain? The issues here is we need to essentially match one person with their demand of the power with multiple people who are actually supplying the power. So we need to have that smart contract to make sure that it transacts smoothly, and we don't want to actually sit in between them. We're not centralized, we're completely out of it. We can never see the people's information. It passes directly from peer to peer. To just show you our roadmap, we're technically right now in phase 1, and we refer to it as our block mining phase. But if you think about what we're trying to do, we're trying to build two sides of the coin, both the supply and the demand. So in this case, we first have to build the supply of the overall computers and processors. So we can use any processor that's out there, whether it's an iPhone, whether it's a tablet, anything. But we need to get them online. In order to get them online, we need to compensate the people that put them online, and they can't have only partial use. So if they put it online, they need to get fully compensated for when they have it on. So right now we have essentially an optimized algorithm to run block mining, and basically will run depending on which CPU or GPU is within the network, and we'll optimize that and run and mine during those time periods. The second one is essentially building out the SaaS system. And so it's allowing software as an application in its current form, what we think of, anything from Salesforce, to run in a decentralized environment. And it's not something that's happening right now. Then phase 3 is what people have been talking about, is just the development of the decentralized apps as well, but also to allow this so that they could make this plug and play and easy to perform as well within the network. And the last one is obviously bringing all of it together into one. So we've touched upon this, and I know it's late, but how do we do it? In order to get people to utilize it, we need to make it as simple as possible. So we need to be able to use any device. So we can connect at this point to a Linux-based system, we can connect to a Windows-based system, or we can connect to an OS X system. And we have to do it with one simple app, so that even my mother can go on and say, yes, I want it to run. She can either turn it on and say, when I'm not using my device, you can run it. And when she wants to use her device again, it automatically shuts down, or she can set it for a certain time period. I want it to run from 6 p.m. to 6 a.m. because I'm going to be sleeping. This is actually our current working prototype that we have on the iPhone. And this is actually a copy of what they have. So we already have it in existence. We've already tested it. We've run it over a 4,000 node program. And this is actually what it looks like too for the beta version for the Macintosh. This is actually running on my computer right now. It's not connected to the internet, so it's not harvesting anything. This is our overall team at this point in time. What you can really see is the computer science. They've been dealing with this for past, as I said, 3.5 years. They were actually up for the Gordon Bell finalists for supercomputing on essentially this exact thing for parallel computing and how to run the processing and the SAS all in one. So as we said, we're Symbioses. We're currently in our private sale, but we're also looking for people who are willing to test our beta application. And please, if you have any further questions, please let me know.
Right. Do you have any questions? Yeah.
Here, let's try that.
So in your slides you talk about fog computing. What do you mean with it? Can you define it?
Yep. So what we're referring to is, I'm sorry, say the fog or fork?
Fog.
Fog. Okay, so fog depends on who you ask and how they present it. They'll call it either edge or fog computing. Fog is essentially that it's not one processor or one centralized processor occurring, but it's multiple all at once. So what they're essentially doing is running, let's say you take one calculation that you need to be done, you break it into multiple pieces and run it throughout the network. The benefit of fog computing is the closer you get to the end result that's needed, the less transportation, so the less latency in terms of the response.
Yeah, it's already said there's a lot of pretty cool that you're working on this for such a long time. That's great. There are also projects that are trying to do something similar. How would you compare yourself to like maybe Storage or CI coding?
So, yep. So I don't, yeah. So as I said before, in terms of, we don't see them as competition necessarily as much as complements to our system. So if you think of storage, essentially what they're doing is we can use any of their excess capacity, and we can essentially, so if you go back to the connection, sorry, give me 1 second. So if you think of it, we can add them into our network so that one person can go and get both storage and computing capacity all at once in one shop, instead of having to go to storage and then try and go to what we'll call it iExac or any of the other competitors on the computing side. And so that's the difference of them. They do not have, they cannot overlap at this point in time. They're all individually and siloed, and their protocol cannot interoperate.
So you interact with all those protocols?
We can, yep. We have the ability to ride on every one of their protocols.
Is there a technical white paper?
We do have a technical white paper. It's on our website, which is symbioses.io. And I'll show you, just so you can kind of see how we had a little extra on top of it. And it's essentially through the API. This is in the technical white paper, and it goes into much greater detail than I'm giving it at this point in time.
All right, I'll do that.
And if you have questions, please, I'll give you my card as well.
Yeah.
We have time for one more question here. Hands up. Question for this great project over here. Okay. So you've got to keep the mic pointing this way, okay? Otherwise it's going to feedback. There you go.
Great project.
Yeah, thanks.
I just wanted to ask real quick. Your app sits on the iPhone, correct?
The app sits on the iPhone, correct.
Okay. So how do you, because everything you do on your app gets stored or gets forwarded to Apple servers, right? And then gets distributed. How do you maintain the integrity of the data?
Yep.
And by the way, the NSA is more powerful than Facebook.
Yep. Yeah. Thank you. Good. Okay. Great question, but I want you to also think about an iPhone. And how many people have the iPhone and essentially you run out of storage space on it because you're utilizing it for yourself or for your pictures? Most iPhones, we actually don't want the storage capacity within it. We're looking for the compute capacity off of it. Because the computer that's sitting on that system is as fast as what the mainframe computers were essentially 12 years ago. And so when we can take the computing capacity, all local, so just think about everything that's sitting in this room, and we can aggregate all of them into one, we have much more power for the computing, and we can send the storage somewhere else locally. That device is not optimal for exactly the reason you're talking about in terms of one, having the information sitting on it, but two is that it's not an optimal in terms of it doesn't have that much storage to actually utilize. The computing is what's more beneficial for that.
All right, fantastic. We're out of time for questions. Let's give us a round of applause. This is a fantastic project.
Thank you very much.
Thank you.